do translations. If you remember, there are four, voices off please. There are four types of transformations. We have translations, reflections, rotations, dilations. Today we're going to focus on translations and reflections. Okay? So remember, translation is when you move every point of a figure the same direction and the same distance. I'm so glad. Direction and distance. A translation can move a figure left or right,
What if we don't remember any of them?
up or down. You'll be fine. Translations are also thought of as slides. When you were in 5th grade, you probably were taught slide, flip, turn. Okay, who remembers what the difference is between how you label a pre-image and how you label an image? What do the image labels have? The little apostrophe, right? And we call them prime.
Can you go up?
So we're going to look here at number 1, and we're going to determine the ordered pairs of our pre-image. So we have A, B, C. And it wants us to translate the figure 5 units to the left and 2 units down. So I'm going to take each point and I'm going to go 5 to the left and 2 down. And this will be A prime. 5 to the left, 2 down. This will be B prime. 5 to the left, 2 down. And this will be C prime. So now I can see how I translated that figure left and down. You always talk about left or right first and then up or down second. And then I'll go ahead and fill in the image ordered pairs as well. A prime, B prime, C prime.
Oh yeah, I do. Yeah, Matt, throwing them at my head.
This is not even true.
Yep.
How would I even get
Yep, try to get away from it.
Okay, so let's look now. When you look at the A and A prime, what do you notice? How did we go from 2 to -3? What math would you have to do from 2 to -3? Yep, subtract 5. How about 6 to 1? Subtract 5. 7 to 2. Subtract 5. So X values are 5 less. How about my y values? Is it -2?
Oh, wait.
No, is it? Yeah, y values are -2. Okay, so 5 less for x, 2 less for y. And what did we do again up here? Okay. So do you think there's a connection between these values and what we did to translate? Yes. Right? So if I start out with my regular old xy coordinate, algebraically, I subtracted 5 from every x and I subtracted 2 from every y to get to my new image. It was a pattern. Right? What do you think if this had been x values are 5 more? What if I had gone up 5? How do you think this would change down here? It would be +5. And what if I had gone up 2? What do you think this would have been? +2. So if you are going right or up, you add. If you're going left or down, you subtract. So that's how you write it algebraically. Right or up is going to be positive. Left or down would be a negative. Since these were both left and down, we have -5 and subtract 2 and subtract 5. So now let's look at this second one here. We're not going to translate it yet. We're just going to use what we know, what we just learned, to come up with the ordered pairs for our pre-image and image. So we have D, E, and F. Go ahead and write down our pre-image coordinates for D, E, and F. Don't translate it yet. Just write down the pre-image coordinates. All right, so the directions say translate the figure 4 units right and 3 units up. So what am I going to do to each of my x values if I'm going 4 units right? I'm going to add 4. So x values are 4 more. And what about my y values if I'm going 3 units up? Are 3 more. So we don't even have to draw it and do any counting. We can just use our rules to come up with our new x and y values and then plot them. So what would the x value be for D prime if the rule is to add 4? What as in? -3, good. What would the y value be for D prime if it's add 3? -1, good. How about for E prime? What will my x value be? 0. What will my y value be? 4. How about for f prime? What will my x value be? 1. What will my y value be? -2. Right? Because I'm adding 4 to the x's, adding 3 to the y's, and I knew that because it was right and up. So algebraically, if I start with x and y, I'm going to have x plus 4, y plus 3. And now we can take those new prime ordered pairs and we can plot them. No counting needed because I already found out exactly what the ordered pairs would be. D prime, E prime, F prime. And you can see that it went up, it went to the right and up. Okay. I just took these ordered pairs here that we created using the rule and I plotted them. But if I just go to the right 4 and up 3, that will take me to each of those points. Okay, how are we feeling about this? Algebraic notation, left and right, adding, subtracting, pre-images, images. Solid? Yeah. All right, let's move on to example 3 on this next page here. Can someone tell me what direction did our pre-image go to get to our image? Which way? Left, right, up, down? What did it do?
Up to the right. Up to the right.
Right and down. Right and down.
Where? Oh, that one right there?
We're on this one right here.
Oh. Down to the right. No, it's down. It's left.
Oh, no, it's
up.
It is left up because we're going to always talk about left or right first because of the x values. And we know that it went left because these have the prime notation. So it had to go from here to here and then up. Left and then up. Whew. Good way to start Monday. Right, Hannah?
No.
I can see the confidence just beaming from you. Just beaming. Okay, so let's go ahead and just write down our pre-image and image values. So we have G, H, I, J. All right, you go alphabetical order. G, H, I, J. Oopsies, on the wrong one. What's up? Sure can. It's 2, -1. So if you look,
Are we doing this whole page today?
we're gonna work through. No, we're gonna be skipping around some things. So I made a mistake over break. I let my son figure out and connect to friends through Facebook Messenger so he could like play Roblox and chat with his friends.
I would play Roblox with him.
Right? Well, here was the mistake. I didn't realize, I should have done more research, that by giving him that freedom, it meant he could also call me from his Chromebook, which he does all day long. I'm upstairs, he's downstairs. Hey, Mom, what you doing? I'm downstairs, he's upstairs. Hey, Mom, what you doing? I'm in the car. Hey, Mom, what you doing? All day long.
He calls you?
He calls me. He video, and then he wants me to look at all the cute little, like, filters he can do.
If he calls you in class, you should answer.
Well, he doesn't have his Chromebook at school. It's at home, so he can't do that. But I didn't realize by letting him chat with his friends, I was also giving him the ability to call me.
His mom. I would not.
Did you tell him to stop calling you?
I mean, I don't want him to, no, I didn't, but I tried to shorten the conversations as quickly as possible.
It's like, okay, fine. Like you wanted
Like, I went to get donuts. Hey, Mom, what's taking so long? Well, I'm at the drive-thru, and there's a lot of people that want donuts today. Okay, well, don't forget the donut I want. Not going to forget it. 5 minutes later, hey, Mom, it's taking so long. Still in the drive-thru.
At least he loves you.
He loves donuts, is what he loves. He's not so concerned about me. He's concerned about his chocolate Bismarck from Titus.
How old is he?
7. He's almost 8. He'll be 8 in 2 weeks. Yeah. Okay. No, he's going to get a gizmo. We talked about this.
That's so old, though. You have to get him, like, something newer.
No, the gizmo is perfect because it has restrictions.
I was gonna get a gizmo, but they just decided to get. It's probably gonna break it there.
Yeah, I mean, gizmo's like I'm not signing my life savings away. Okay, so the verbal description, we went left and up. How many units left did we go? How do I get from 2 to -5?
Plus, minus 7.
Left 7. And how do I get from -7 to -3?
Plus 4.
Add up 4. So algebraically, if I start out with my x and y, if I subtract 7 from every x and add 4 to every y, that gets me to my next point.
Wait, how did you figure that out?
So I looked at the 2 and I looked at the -5 and I subtract 7 to get from 2 to -5. And then -7 to 3, I would add 4. And so the left is connected to subtraction, up is connected to addition. Do the line segments of the image and pre-image, are they different? Do they change sizes? Nope. What would have to happen for it to change size? What transformation? Which of our 4 transformations changes the size? Dilation. All right, we're going to skip number 4. We're not going to do that again, but we are going to look down here at 5, 6, and 7. So we don't have an image or pre-image to look at, but we can still figure out what happened here. So if I was going from 12 to -1, what math is that?
Minus 13.
X minus 13. And how about from 7 to 14? What am I doing here? Y plus 7. Because I would go left 13, up 7. I can cross out where it says summarize today's lesson. I'm just going to use this space for that. Getting all this written down?
Yes, we are.
Mm-hmm. All right, how about n to n prime? What happened to the x value? X plus 1. What about the y?
Plus 10.
Y plus 10. So what happened to my pre-image then? Left or right, up or down? Yep, right 1, up 10. Because they're both adding, right? So I'm going to go to the right and up, so it's shifted that way. Do O and O prime by yourself.
Do you think this will be on iLearn?
Yes, I do. Everything is fair game on iLearn. Everything we've talked about from August 1st, I think it's the first day I had you, till today is fair game.
What does iLearn even count to? What's it even for? For teachers to see?
It's kind of to give like an idea of
Their progress.
how you guys are doing academically.
So is it gonna go in any grade book?
No, but it does go with you. Like the documentation of your score on this does stay with your file. That goes with you, like your electronic you. Yep. Yes, Brody.
When is it?
So next week I have Monday's schedule up here. I haven't finished the rest of the week, but you have testing Monday, Tuesday, Thursday, and Friday.
Yeah.
What? 4 days?
Yeah, I was kind of the same. I remember that time. My excitement.
But we only do one rush now.
Yeah.
Why do
Wait,
we have
do we get like a break on Wednesday?
Yep.
Are we gonna like do anything Monday?
I don't know.
Yeah, we're gonna do stuff. Come on. Okay, check your work for number 7. How do we do? -6, -7, left 6, down 7. How'd we do?
Yeah.
Yeah?
Wait, left 6, down 7. What?
Yep. Because I subtracted 6, so that's going to be left 6. And then I subtracted 7 to get from 6 to -1, so that's down 7. Okay. Okay, we're going to move on to reflections. Turn the page.
Can I like next to my house?
What do you ask?
I can reflect my house.
Reflections aren't bad. You guys will be fine. A reflection flips a figure over a line of reflection in order to create a mirror image. Each reflected point of the figure should be in the same distance from the line of reflection on the opposite side. Highlight and identify the line of reflection in each example. So we're just going to do like squiggles. So this would be our x-axis. Because it flipped down or up, we don't know which because they aren't notated with prime. And then this one would be our y-axis as our line of reflection. And we don't know if it flipped left or right because, again, we don't have any notation, but we just know that it definitely flipped over this vertical line. So number 1 here says reflect the figure over the y-axis. So let's go ahead and draw our line of reflection here. So we know that we're flipping to the left, right, and not down. We're going from quadrant 1 to quadrant 2. So we're going to do our ordered pairs. What do you notice about the x values when you look at the ordered pairs? What relationship between the 2 and -2, 7, -7, 2 and -2? Jackson?
They just became the opposite.
Opposite, that's the perfect word. X values are opposites, right? What about the y values? Yep, y values are the same.
How do they not change?
So what's happening, because we're flipping over the y-axis, we're still going to be going the same distances from the x-axis, right? So I'm not going to change this. It's still going to go up 2, up 4, and up 6. But my x values are now in the negatives, so they have to be the opposite, right? If I had started here and gone from quadrant 2 to quadrant 1, they would still be the opposites, and the y values would still be the same. Okay, so algebraically, if we start out with x and y, that's going to change into the opposite of x, y stays the same. So a way to remember that is that if it tells you to flip over the y-axis, the y value will stay the same. What do you think will happen when we flip over the x-axis? X stays the same, y is the opposite, right? So that's exactly what we do down here for example 2. I'm going to draw my line of reflection here. So we just said the x values will stay the same. And the y values will be opposites. So you don't even really have to draw it. You can just tell me what will our image ordered pairs be. Where should our image ordered pairs be? So my x values are going to be the same. So I'm going to have 2, 7, and 2. And my y values are all going to be opposites, which means Hannah is correct. These will also now be positives. 2, 7, and 7. So when I plot these, then they prove that I did my reflection correctly. So then algebraically, I start out with x, y. I'm going to end up with x opposite y. Let's look at one more thing. Let's look at what Bella was talking about over here on number 5. She thinks that transformation was a translation. Is she correct? So if we look here at these two trapezoids, is it a translation? Check out your letter placements. It is a reflection. How do you know that? Because it's a mirror of itself, right? It's not the same in the same place, right? H is not here. I is not here, right? So you can see that this would be your line of reflection. Bella needs to go back and check her notes. That's what Bella needs to do. All right, we'll stop there today. Good job for your first day back.